So great to see everyone this evening. So my name is Paul Ross. I'm a specialist solution architect for in-memory databases on AWS. So I've just put this slide in. There's a US format as well, spelling there, because one of my US colleagues flagged it up when it appeared on LinkedIn. So there we go. A little bit about me. So it's interesting, Ethan was talking about the third sector there. My most recent jobs, I used to work for JISC. I don't know if anyone's ever connected to Edgerome when they've been in a university. So JISC is probably one of the most modest technology companies in the UK. They provide a lot of critical infrastructure. The Janet network, Edgerome, connectivity, lots of digital services to help universities procure cloud services. And they're a non-profit technology company. I then worked for Redis for a couple of years as a partner solution architect. So that was working with big cloud providers to help kind of drive the adoption of Redis Enterprise. And then for the last kind of year and a half, I've been working at AWS. So today, in terms of this talk, I just wanted to talk to you about in-memory databases and why you might use them. We'll talk about what is Valkey, how you can use Valkey on AWS. We'll obviously kind of talk about this intersection of AI and how you can use that with technology such as Valkey, and then just consider next steps. And I've also taken the time to kind of include a few demos as well. So is anyone here familiar with technologies like Memcached, Redis, Valkey? Maybe the hands up moment. Redis, okay, cool, awesome. So why might you use an in-memory database? So if we think about latency, it kills the user experience. Kind of modern applications, they need to be fluid, fast, responsive. So that's one reason you kind of use these technologies. Improving database performance. So if you've got a relational database, something like Amazon Aurora, then you can use a technology like Redis or Valkey to cache data and use caching patterns to increase the read throughput that you can get from that database. And then if you play any mobile games or any type of game, typically games developers are using technologies like Redis and Valkey for things like leaderboards to offload all that logic to the server. So they don't have to maintain scores in their application. They can keep these scores in an in-memory database using something like Elasticache. So just kind of walk through the kind of caching patterns here. So here we've got an EC2 instance. It's writing data to our RDS cluster, and it's also reading data. At some point, if we want to scale up, we have to kind of keep adding more read replicas to the RDS database. And so that's where technology like Elasticache comes into the mix. So you can see here we've added Elasticache, and that means that we can store the data in memory, which is extremely fast. And using caching patterns like cache aside or lazy loading, we can take that data from RDS, serialize it, and then store it in Elasticache. So in terms of the benefits, we can obviously scale faster and at lower cost. You get access to lower latency data, and you can also get more throughput by adding this caching layer in front of the database. So if you, I don't know if anyone here is using Elasticache currently in their cloud environment. Okay, we have a couple of users. Does anyone want to call out the engine they're using?
Redis.
Okay, Redis OSS. Yes, so Probably the most commonly used engine on Elasticache is Redis OSS, and it's one of three. So in March 2024, Redis, the company, they changed the license that was attached to the open source Redis core. So it was a BSD3 license. And so these license changes meant that for cloud providers, it was much more restrictive in terms of offering Redis as a managed service. So that's where we saw a fork, which a fork was created, which is known as Valkey. And so, yeah, I've just taken this from GitHub. So this is basically the pull request from when they changed the license. So you can see here, Redis adopts dual source available licensing. But the kind of main thing I'd call out there is the thumbs down. So it wasn't, I'd say in terms of community feedback, it wasn't the most popular decision in terms of how this change was shared with the community. So like I say, we ended up with a fork, and this is known as Valkey. And Valkey was a direct fork of Redis OSS 7.2. So we took Redis OSS 7.2, forked that, and we ended up with Valkey, which is a high-performance key-value data store, and it's backed by the Linux Foundation. That's really key in terms of the momentum that we're seeing with the project now. So it is a drop-in replacement for Redis OSS. I've just kind of put some of the versions here for you to give you a kind of overview of the way this has kind of panned out. So it's a bit like a tube map, but we had Redis 7, which was available on Elasticache. It still is available on Elasticache. Redis has kind of gone their own direction on the vertical path here with their own licensing. And then we saw Valkey get forked from 7.2. That's now this open source community project, and it finds its way into Elasticache with Valkey 7.2, Valkey 8, Valkey 8.1, and most recently Elasticache 8.2. Backed by industry leaders. So I'm here from AWS, but we have a number of other kind of exciting industry sponsors. So you'll see Oracle, Google. Google's done a lot of work on the recent search modules. Interesting independent software providers like Ivan, and managed service providers. And you've also got the big telecoms companies involved in the project as well. And so I just wanted to show you this slide. So if you use Elasticache today, if you're using our Graviton nodes and you're on an extra large Graviton node, you get this feature called enhanced I/O and multiplexing. So the analogy I like to use here is if you've landed on a flight and they only open one door, it takes ages for all the passengers to get off. Sometimes they open the rear door and then everyone cheers because you can get off the plane much more quickly. And enhanced I/O is very, very similar. The engineers realized that a lot of the time spent time elapsed on a Redis server was spent in the network stack. So they took this new approach of offloading the network I/O to different threads. And so these threads can run on separate virtual CPUs on the instances that you're using. And it means that you can get a lot more traffic in and out of these cache nodes, but you're still using this single-threaded processing engine for very fast microsecond response times. And so a lot of that technology was developed by AWS, and then it's been committed to the Valkey project due to the fact that it's a community project with all the development happening in the open. So you see we get more throughput, 230% more throughput, 70% lower latency, and also memory efficiency as well with this service. This is the slide just to show you the difference. You've got Valkey 7.2 on the right and Valkey 8 on the left. So with latency, lower is better, the blue boxes, and then obviously you can see that the throughput's gone up pretty significantly as well. If you deploy Valkey on Elasticache, you get these benefits, so 40% less memory, improved throughput, and it's also new developer capabilities available by using this engine as well. It's just a slide here to show you, if you do online upgrades, what you can expect in terms of memory savings. So here we can see up to 27% memory saving by upgrading to the latest version of Valkey. And this is obviously critical if you're storing data in RAM, because it tends to be more expensive than running databases where you're storing data on disk. So typically, workloads on Elasticache are smaller due to the fact that people are using it as a kind of transient data store for caching purposes with time to live. And this slide just shows you, so we have this data structure known as a sorted set, which you can use in Redis and Valkey. So this is very large collections that you can store things like scores in. So here we've got 50 million items in a Redis sorted set. But by storing those items on Valkey, you can see that not only is the performance improved, but our memory consumption drops by about 1 gigabyte for that data stored within the sorted set. So if you're storing a lot of data in your Elasticache cluster, then these benefits really start to add up in terms of data storage. Valkey modules. So you can get modules with Redis. You can now get modules with Valkey. So you can get access to JSON. So you can store JSON natively in Valkey. You can use Bloom filters, which are probabilistic data structures. And there's also a search module, which I'll come on to soon. And this is just to give you an overview of the different services that you can use on AWS to get access to Valkey as a managed service. So it's Elasticache, node-based, Elasticache serverless, and also MemoryDB that support the Valkey engine. I'll just kind of skip through that one in the interest of time, but one of the really popular services now is Elasticache serverless. So if you think about node-based Elasticache, you have to set up your VPC, you have to set up your subnets, then you have to choose the node types that you want. You have to think about all the operational tasks in making sure that it meets the demands of your application. With Elasticache serverless, this all goes away and it becomes a completely seamless, automatic process in terms of how the service meets demand for your application. And so you can see here, you can create a cache in under a minute. At P50, we're looking at kind of 700 microseconds response time, and you can store up to 5 terabytes in your serverless cache. And then here you can just see how the architecture differs from node-based Elasticache. So your client application connects to this proxy layer. The proxy exposes a single endpoint. That's known as kind of like a virtual shard with a reader endpoint and a replica endpoint. And then the proxy is responsible for everything that happens behind the scenes. So all these shards, which you can see at the bottom of the screen, they're dynamically allocated as your application scales up and down. When you need more traffic, you'll get more shards. When your application has less traffic, the service will scale in and scale down to save you costs. If we just consider capacity management, this slide kind of shows what typical applications look like in the working day. You'll have peaks, troughs, and then you've got your provision capacity in the blue line. So if you're using on-demand cache nodes, you're paying the same price every hour. You've got that line. With serverless, every time you're below this blue line, you're saving costs because you're not paying for capacity that you don't need. And then just to get kind of a little bit more geeky, if you're wondering how this works, your data basically gets routed through a network load balancer to this very large proxy fleet. So the proxies are responsible for routing requests to the cache nodes behind the scenes. And we use those similar techniques that we talked about earlier, enhanced I/O and multiplexing. So the requests are being batched and they're being sent to the cache nodes to be more efficient over the network. And these cache nodes are dynamically allocated to the actual dedicated hosts that run in the data center. So unlike EC2 instances, with Elasticache Serverless, the CPU and RAM is kind of dynamically allocated to the hardware as your application needs it. So instead of taking minutes to deploy a new cache node, it can be done in seconds. Just got a very short demo here to kind of show you how Elasticache Serverless works at scale. So here we've got some load test clients on the left-hand side. We've got an Elastic Beanstalk service running in the VPC. And these are fully managed application servers running web application, Node.js web application code. So this gives us an API, and then the API routes requests to the cache layer behind the scenes. So if we were running a weather application, it would look something like this. And just check it's playing. It's playing. So you can see here we've got a kind of fictional weather forecast. It's nothing like today. Seven entities within the web page. So each of these forecast items maps to a structure in Redis or Valkey. And then we can basically pipeline 7 requests to the Elasticache Serverless cluster, get all that data back in one payload, and then present it to the user, but extremely quickly as well. So when we change to a different city, we're going to change there. You see it comes back pretty much instantly. So we're not waiting for the data to come back to the application like you do with some other types of databases. And so what does this look like behind the scenes? We've got here the JSON payload that you would get if you connect to the API. So you've got kind of top level stuff here, and then an array which contains the forecast. So within the forecast, we've got the different weather forecasts for each day of the week, and then some metadata. And we can see here that we're getting this in about 1 millisecond from the Elasticache Serverless database. So that includes the network hops, getting it from the cache, and then sending it back to the client. And so one of the interesting things about Redis and Valkey is if you log in and do kind of a ping, like it obviously shows how simple the technology is, but it doesn't really show it at scale. So this is to really show the load testing approach. So has anyone used JMeter in terms of the app development? Yeah. So it's basically just throwing lots of requests at the API service, application servers. So about 40,000 requests, and then we add more traffic to simulate a spike in traffic. So this gives us about 40,000 API requests per second. And then because we're pipelining, that means that we are sending about 500,000 cache operations to Elasticache Serverless every second. So this diagram is from CloudWatch, and you can see here we start our load test, about 40,000 API requests per second. Then we add more traffic. We get that sort of head and shoulders artifact in the graph. But interestingly, you'll see here the latency stays very consistent, half a millisecond for these requests, which are hitting Elasticache Serverless. So it's very scalable, it's simple to use, And these Node.js servers are just connecting to this single endpoint all the time. You don't have to worry about the underlying topology of the cache in any way. It's about halfway through, Ethan.
Yeah,
sure.
20 minutes so far.
So if you were to upgrade your Elasticache cluster from Redis OSS to Valkey today, you can expect 20% saving by just changing engines. You're smiling. And then if you're using serverless, then it's 33% saving. And you can start with a smaller cache with Valkey on serverless as well, 100 megabytes. So very good for dev and test workloads or POCs that you might be working on. I did get this feedback from Cambridge. Someone said, well, I don't know what Elasticache costs anyway, so you're giving me relative costs. So I just put this together. So if you've got 3 cache nodes, R7G extra large, so 1 primary, 2 replicas, that's going to cost you just under $1,000 per month with Redis OSS. That would drop to $765 if you were to upgrade to Valkey. So it makes good sense commercially, and you also get better performance by switching to Valkey as well. If you are a developer, then you might be, do we have any Python devs in the room? Java, C#? No C#. Well, so Valkey Glide, it's what's the acronym? A language independent driver for the enterprise. So with Valkey Glide, you can use your programming language of choice, and you use this client library. And the client library is a multiplexer. So it typically just uses one connection to very efficiently batch commands and pipeline them to Elasticache or other Redis and Valkey compatible services. But it's got a lot of additional business logic in there to ensure that your application is reliable and resistant to changes that might happen server-side. So Valkey Glide's open source. It's also backed by engineers at AWS. And so this is a good option if you're starting a new project, building something with an in-memory database. And then one of the most recent innovations is Elasticache version 8.2 for Valkey. So with this version, you now get a vector database as part of your Elasticache cluster. So you get this vector search module at no extra cost, and you can start using that immediately once the cluster's up and running. So if we consider vector search, are people familiar with semantic search and this kind of concept? So here I've just put in some kind of phrases into the database and then indexed those data structures. And then we're just making very simple queries like a red cat, a red tabby, for example. So you can see here, semantically, we get back a match for a black cat due to the cat phrase, but it's kind of done a bit of a mismatch when we search for tabby, because it doesn't quite recognize tabby in terms of how that relates to cat, or tabby and cat. But when we put in a red tabby, you'll see that we get a semantically similar match. And then it's similar if we put in a dark canine, we get back a brown dog. And then if we put in a dark feline, we get back a black cat. I own a black cat as well. So that's, in a nutshell, sort of semantic search on Valkey. And this unlocks new caching patterns. So we talked about lazy loading and cache aside. With semantic caching, if you're building a generative AI application, some kind of user query comes in, text, for example, from a chatbot, you encode that by using an embedding model, and then you have the user query in the form of a vector. So you can then send this vector to the Elasticache service and look for similar matches. So for example, if we were building some kind of missing pets application, we could use those kind of queries and do lookups on something that's semantically similar rather than an exact match. So the example I often point to is a car manufacturer. They might have a user say, what's the gas mileage? User B might say, what's the fuel economy? So it's kind of the same question, but it's different semantics. And so by building a semantic cache, we can basically skip the reasoning and the inference that we do with the large language model. So it cuts down on tokens, cuts down on inference costs, improves latency, improves performance.
Sorry, Paul.
Okay.
Yeah.
For semantics.
Yeah.
For Valkey, you have to store all of the vectors inside Valkey in memory so it actually works, or does Valkey does something smart and it communicates with, let's say, a vector database to do, let's say, a semantic section there?
Yeah. So
if I have for some good reason, I have like a terabyte worth of vectors.
yeah.
Do I have to put that in Valkey for it to work? Or?
Not necessarily. You could use this with another vector compatible database. So last week we were talking to customers about using Aurora with Postgres and the PG vector capability. But if we take that approach like cache aside, you could just store vectors temporarily in the cache and the responses in the cache temporarily during peak load, for example. And then you can store the LLM response alongside those vectors in the cache as well. So it's kind of different ways of doing it. But then some customers do store very large amounts of data in Elasticache as well.
So we're still kind of forced to basically query the database anyway, if the cache doesn't even exist.
Yeah, it all depends on how much data you're storing and where you want to store it, really.
And what do you think is a reasonable amount of, let's say, vectors to be stored? Or consider, because vector search is very interesting. If you did a KNN search, what do you think is the best strategy to let's say pull a reasonable amount of vectors into the let's say Valkey database?
Yeah, I mean, it's interesting because with the new module, it works across shards. So you can potentially store billions of vectors in Elasticache if you choose to do so. But yeah, as your data volumes grow, you're going to need more cache nodes or potentially a bigger serverless cluster. So it's just something to consider in terms of your architecture. So that's kind of semantic caching, and then building on that, we have agents now. So, sorry, just go back to that slide. So, obviously, you have kind of like Gen AI assistants that do fairly simple tasks with a clearly defined set of rules. And then there's generative AI agents that achieve a singular goal or can do more complex tasks. And then there's this concept of agentic AI where we have fully autonomous agents doing tasks by themselves. There's less human oversight. They can potentially work with other agents. So this is where we introduce the concept of tiered memory management. So you can see here, this is a kind of travel application, for example, that's serving user requests. And in this architecture, we've got our agent We've got system prompts that we're sending to different different large language models. We're contextualizing that with data from databases or something like Elasticache. But interestingly, we can start adding memory modules as well. So in this case, we've got short-term memory and long-term memory. So you can use something like Elasticache as a short-term memory layer for your agentic AI applications. So you could store here the session state in the way that you do with a traditional 3-tier application. You could store the user context, user profiles, and you can also use this for checkpoint mechanisms in terms of an agentic AI workflow. So if you're interested in this, you can get started using the Strands SDK. So this lets you build agents very simply. There's a Mem0 plugin, which allows you to do semantic search on data that's stored in Valkey, and then you can use that as a memory for your agentic AI. And so the cool thing about doing vector search is that the agent can query collections of memories, not just single key value records within Elasticache, which is what you had to do before you had access to vector search. So this gives you a lot more flexibility in terms of how you build your agents. And you can see here just some very kind of simple code in terms of establishing an agent, adding memories to the data layer, and then querying those memories as well. So if I just hop out of this for a second.
Can I ask a quick question?
Of course you can.
How does that compare with what the memory function is in Agent Core?
That's a good question. Yeah. So with Agent Core, you get a fully managed memory capability. As far as I'm aware, I think it uses Dynamo under the hood, but it's not very extensible. And if you've got data that's already in an existing service, then you can use different parts of the Agent Core framework to build your own business logic to access something like an agentic memory in Valkey, if you so please. Yeah. So just got a kind of a very quick demo here. I think it's if we do ft.info, ft.list, you'll see here that we've got, it's not very visible, is it? You can see here that we've got our indexes in Elasticache. You can do ft.info to get information about the index. So you can see here we've got an index of type vector, got the cosine distance. We're using HNSW as the algorithm for our vector search. So that's what it looks like inside Valkey. And then just have here a kind of very simple agentic AI application, which is using Strands. So the kind of key thing here is we're asking questions where we don't have any context. So you can see here that I've stored some memories in the cache. We're going and querying those memories using vector search, and then passing the response that we get from the vector search to the large language model to do the reasoning. So it knows that I was traveling on a train to Paddington, and tell me about the event. So you see here, it will create an embedding for that query, and it knows that I'm going over to arrows to do a meetup. So this agent has memory about my context, my itinerary, and that will be persisted whether we're kind of interacting with the agent today or whether I interact tomorrow. If you think about a lot of Gen AI apps like Gemini and things, they're quite often stateless unless you explicitly turn on the persistence. So it's just to show how you can use this technology quite simply with something like strands, Valkey and Mem0. So you see here it's giving me a little overview of my profile as well. So just to wrap up, we've got an MCP server. If you want to interact with your cache using MCP, Model Context Protocol, we've got an MCP server for Elasticache now. Valkey 9 is available. For that demo, I'm using something called Valkey Bundle. So if you pull down Valkey Bundle from Docker, that will give you search, Bloom, JSON, all as part of the Docker container. Valkey 9 is available, also includes hash field expiration. So this is what hash field expiration looks like. Lots of developers wanted to expire specific attributes within their hash without deleting the entire hash. So this lets you do a more granular expiration on specific fields within hashes, which you could use for these agentic AI apps as well. There's a QR code if you want to learn more about Elasticache. So I'll leave that up for a couple of seconds. But otherwise, just thank you for your time today. And it was great to meet you all, and hopefully you now know more about Valkey.